That quantity there equals cosine squared x.
I think that's magnificent, Gabe. Thank you. This is cosine squared. Remember, on your colored sheet, you have something that says cosine squared plus sine squared equals 1. If you have not already added to the colored sheet, I want you to move the cosine squared over so you have sine squared equals 1 minus cosine squared. I want you to add that to the colored sheet right next to this one. And if you move the sine squared, you'll have cosine squared equals 1 minus sine squared. We have to recognize that things on the paper are equations. And so they can be rewritten, they can be rearranged. And if you rearrange that, get sine squared by itself, it's 1 minus cosine squared. Get cosine squared by itself, it's 1 minus sine squared. So Gabe says I'm going to look at this problem right here, and I'm going to change this into cosine squared, because that's what it is. 1 minus sine squared is cosine squared. Okay? Twan, need your camera on, please? Now, who has an idea about what to do next?
Wouldn't you change secant to 1 over cosine?
Indeed you would. So secant squared is 1 over cosine squared. That's on the paper too, but really this one you should already know because secant is the reciprocal of cosine. So secant squared is 1 over cosine squared. And then this is just cosine squared over 1. And what's going to happen when you multiply those together? That's a multiply there. What's going to happen?
Everything's going to cancel out. Cancel.
And the answer is just 1. That's it. 1 is the answer. Remember, your job on these problems is to simplify. So you want to simplify, cancel things out as much as you can. All right, let's look at the next one. Now, this one has thetas in it. I'm going to go ahead and use the thetas, but if you don't like theta, if that's hard for you to write or you don't understand it or whatever, just change it to an x. Okay? Antoine Butler, please turn your camera on. Brooke, I need yours on too, thank you. Okay. So now, who's got an idea? Think about some of the things we did last time.
Can't you change cosecant to 1 over sine x, and tangent to sine over cosine, and then secant 1 over cosine?
Very nicely done. Very nicely done. So, when we don't know what else to do, guys, it's a good idea to change everything into sines and cosines, because our hope is that we'll be able to cancel. So if everything's the same, everything's sines and cosines, it gives us a better chance of canceling. So cosecant is 1 over sine, tangent is sine over cosine, and secant is 1 over cosine. All right? Now, keep in mind, this is a plus. So you can't cancel here and here. This is like a little problem all by itself because these are times. So what happens here? Does anything happen here? With this stuff right here?
Sines cancel.
They do.
Sines cancel.
And leave you with just 1 over cosine plus 1 over cosine. Now wait a minute. Those are fractions being added. And when we add fractions, we have to have a common denominator, right? And we do. So our common denominator is cosine. And what's our numerator? 1 plus 1. So the answer is 2 over cosine.
Why did you multiply the first one and then add the second?
Look at the original problem. What sign is right in there? On the paper, the problem. Yep, I'm not making that up. I'm getting that straight from the problem. Now, for this, if you wanted to, you could make this 2 times 1 over cosine, which is 2 times secant. I'm not saying you have to do that at all, but you could. You could. 2 over cosine is the same as 2 times secant. So either one of those would be the best answer. Either one. All right, let's look at the next one. Sine squared cosecant squared minus sine squared. All right, this is another one. This is a multiply, that's a subtract. So I can't do it all at once because of the subtraction in there. All right, what do you suggest? Anybody see anything at all we could do to start trying to simplify this?
Change that cosecant into 1 over sine squared x.
Perfect.
And then you'll have to put the sine of the log.
It makes it easier to multiply if I have them both lined up as fractions. I hope that doesn't confuse anybody. So I've changed, as Gabe said, I just changed my cosecant squared into 1 over sine squared. Now, these are multiplied, so I'm allowed to cancel. What happens with these two right here?
The signs and the ones cancel out.
So all you're left with is 1, right? This just makes 1 minus sine squared. Whoa, 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 wait a minute. I think that's on your sheet. At least if you did what I asked you to, it's on your sheet. What did you? Yes, exactly. 1 minus sine squared equals cosine squared. Beautiful. So that's the answer to the question. So again, we start with this big ugly thing and we use our brains and our colored sheet and we whittle it all down and it's just cosine squared. Great job. Okay, where am I? Ready for 16 now, okay. Now this is a little bit different. Anybody have a thought about that? Well, what does it mean?
It's not 1.
Now be careful. To get 1, it has to be sine squared plus cosine squared. And that's not what we have. We have sine plus cosine. But it's a quantity. So I don't square each one. What do I have to do if I am squaring a parenthesis? What process do I need?
Distribute?
Yes, otherwise known as FOIL. The actual name is distribute, that's right, that's perfect, but we usually call it foiling. But distributing is exactly what it is. So we have to take sine plus cosine times sine plus cosine. Groupies, this does not mean you just square each one. That's not what that means. That means you are squaring the whole parentheses. So now we're going to do our FOIL. So we'll do first, what's sine times sine?
Sine squared.
Yep. And what's sine, I'm doing outside now, what's sine times cosine? It's just sine times cosine. You can't really do anything with that. How about the insides? Isn't that another sine times cosine on the inside? And then the lasts are cosine squared. Now, gang, you have a sine squared plus a cosine squared, right? And whenever you have a sine squared plus a cosine squared, you can add them together and get 1. So the circled things make a 1.
1.
Yes, good. Now, what about the middle two? Is there anything I can do with those?
Can they cancel?
They would if they were being subtracted. But since they're being added, it's like having one apple and another apple. You're adding them together. So what are we going to have?
2 of each.
Yeah, we're going to have 2 of them. So we're going to have 2 sine, cosine. And that is the answer to the question. One of these plus one of these makes 2 of them. Nate, if this had been a minus sign, they would absolutely cancel. Absolutely. But since it's a plus, they won't. We have to add them together. All right, anybody have a question about that one? All right, there's only one more, guys. On this paper, anyway, in our notes, one more. So here we go. What do you think about this one? Cotangent minus cosecant and cotangent plus cosecant. All right, anyone have an idea when you look at this problem, what do you think?
Do we FOIL it?
Absolutely, I would. I absolutely would FOIL it. I have a parentheses times a parentheses. It's just like what we had over here, only this time they're not exactly the same, but they're close. So I'm going to get cotangent squared. Outsides will give me cotangent cosecant. Insides will give me the same thing, but this time it will be negative. Does everyone see that? So it's going to be minus cotangent cosecant. Remember, when I multiply, I can do it in either order. So I can say cosecant cotangent or cotangent cosecant. It doesn't matter when you're multiplying. And then my last terms will be minus cosecant squared. All right, so tell me what you think about that.
You can cancel the middle.
Yeah, absolutely, those cancel. So now I've got cotangent squared minus cosecant squared. Now, you have some options here. What do you think when you look at this problem? What would you do if you were stranded on a desert island and I wasn't there to help you? What would you do?
Wouldn't you change cosecant?
I would.
100%.
Yeah, okay, and you can do the same thing with cotangent. What is cotangent?
1 over
Cosine over sine.
Yes, it's cosine over sine, that's right. So I will change this, and since it's squared, it'll be cosine squared over sine squared. And cosecant, somebody already said, is 1 over sine, and it's squared also. Now, I have 2 fractions being subtracted from each other. I need a common denominator, don't I? But what's the good news?
Yeah.
Already have it. So I have cosine squared minus 1 over sine squared. They already have the same denominator. So when they have the same denominator, I can write them as 1 fraction. Now, I want you to, this is a tricky one. Lindsay, you and I talked about this morning. You remember? Can you share what we discussed? Nice and loudly for everybody.
So since the one is on the other side, if you did -1 plus sine squared, and then you put a negative in front of the cosine squared, or either other way around, depending on the order of the equation, it would end up being -1 plus cosine squared equals negative sine squared.
Exactly. So here's what I want you guys to pay attention to. You have written on your paper that sine squared equals 1 minus cosine squared. If that isn't already written on your colored paper, I've now asked you twice to do that. Get it written on your colored paper. This is another form of cosine squared plus sine squared equals 1. We're allowed to move things around. Now, that is very close to this, but would you agree that it's backwards? This is backwards. If we multiply through by a negative, that thing you have written on your sheet, then cosine squared minus 1 is negative sine squared. So when this is backwards, it's the negative. So this is negative sine squared because it's turned around. 1 minus cosine squared is regular sine squared. When you turn it around and say cosine squared minus 1, you get negative sine squared. Thank you, Lindsay. Very good. So this, because it's backwards of what I have written on my sheet, it's backwards of this, which is what's written on my sheet. It's negative sine squared. Well, now I have negative sine squared over sine squared. So that's just going to be
-1.
exactly. So that one simplifies all the way down to -1. Okay? Now, I'm going to do a little bit more practice before we move on to the next section. We'll be having a quiz, 2-problem quiz, over this kind of simplification next week sometime. I haven't figured that out yet with all this virtual stuff going on, so I'll figure that out and let you know. But so we're gonna move ahead, but I want to practice a little bit every day just so this stays fresh in our mind. So, trying to remember ones I've already done. All right, so the quiz is going to have basically 2 kinds of problems on it. One kind of problem is going to look like this. All right, so I'm kind of making that up because I've already done some on the sheet. So I'm making that one up. So write that one down on a piece of paper. This is all multiply. Oops, everything here is multiply. One big, long, massive multiply. So, who's got a thought on how we should start this problem? When we finally get around to a quiz, it's going to have a problem like this. What do you think we might want to do with that?
Switch cosecant and secant.
Okay, and tangent and cotangent. We want to take the whole string, guys. When the problem is a bunch of functions, just blah, 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 You want to change them all into sines and cosines. So, what is tangent? Look at your colored sheet. You need to
Sine
start.
over cosine.
Yep, we need to start memorizing these. All right, what's cotangent?
Cosine over sine.
Yep. Now, sines we don't change. Sines and cosines we don't change. Because I am just having this block of fractions, I'm going to write that sine as sine over 1. You don't have to do that, but it helps me keep track of where things are to make it into a fraction. All right, what's secant?
Whatever cosine.
Yep. Now cosine I don't change. That's going to be cosine over 1. What's cosecant?
1 over sine.
All right, here we go. Now, it's all multiply. There's no adds or subtracts. So what am I allowed to do if it's all multiply? Just start slashing away.
Cancel.
Yeah, that's right.
Cancel.
That's right. So here we go. What will cancel? Well, that will cancel. That will cancel. That, oh my gosh. Did it all cancel out? Did you get it to all cancel out? Can someone nod or say yes or something? Yeah, so the answer is just 1. Everything canceled, so the answer is just 1. Of course, that doesn't always happen, but it happened this time. All right, let's try one more of those. We'll practice one more like this big long string of stuff. So let's suppose we have cosine squared, cotangent squared, secant, tangent, cosecant. Okay, that's enough. All right, so here we go. Write that down and see if you can get going on it. Okay, so what do we do with the cosine squared? N-O-T-H-I-N-G, nothing. Cosines and sines, we don't change. So I'll write it as cosine squared over 1. But what about cotangent squared?
Cosine over
And since it's squared, it's going to be both of them squared. Don't forget that. Cotangent is cosine over sine. So cotangent squared is cosine squared over sine squared. You keep the power. Secant.
Whatever cosine.
Yep. Tangent.
sine over cosine.
Sine over cosine, yep. And cosecant.
1 over sine.
Yep. All right. Now be careful because these are squared. So in order to cancel, okay, do you see how I have 2 cosines down here? So that will cancel that out. Would you agree with that? It takes 2 to cancel out a square. These guys will cancel. And what am I left with?
Cosine squared over sine squared.
Exactly. And tell me what cosine squared over sine squared is.
Cotangent.
Perfect. Squared. Yep. There's your simplified answer. Very, very good. Does anybody have a question about that? Okay. So one of the quiz questions, you're gonna have two on this quiz, and one of them will be like these, where it's just this long string of functions. You rewrite them and cancel. You will not have your colored sheet, so it is important that you are memorizing those. Hopefully you're getting close already just because of this practice we're doing. All right, the other kind of question on the quiz is going to be something like this. It's going to use the squared, those three squared equations on your paper, on your colored paper. Okay, so look at that numerator. Have you ever seen that before? Have you seen that numerator before? Like on your colored sheet.
It equals secant squared.
It does. So that equals secant squared right on the sheet. So when you have memorized your sheet, when you see, not the whole sheet, just the 8, just the first 8 that I had you box in. When you see 1 plus tangent squared, you're going to immediately say, oh, that's secant squared. Now, what about the denominator?
It's cosecant squared.
It is. There's an identity or an equation or a formula, whatever you want to call it, on your colored sheet that literally says 1 plus cotangent squared is cosecant squared. Now, this means secant squared divided by cosecant squared. That's what this means. That's a division problem. Secant squared is 1 over cosine squared. That's again from your sheet, hopefully from your memory. Divided by 1 over sine squared. Now I've got fractions being divided. What do I do when I have fractions being divided?
Multiply by reciprocal.
Exactly. So this is going to be 1 over cosine squared times sine squared over 1. Now nothing cancels, but I can multiply. And what would that give me when I just multiplied?
Cosine squared plus sine squared.
Okay, now be careful, we're multiplying. So when I multiply fractions, I just multiply straight across. So what am I going to have on the top?
Sine squared.
Yep. And on the bottom, I'm going to have,
Cosine
Yep.
squared.
which is what? What is sine over cosine?
1.
What? Sine over cosine?
Oh, no.
Now, if these were added together, it would be 1, but they're not. They're being divided. So what's sine over cosine?
Tangent.
There we go. And since they're squared, it's going to be squared. Okay? So, we don't have any, this problem, once we got out of the first step, there are no additions or subtractions in this problem. It's all divided or multiplied. Okay, so don't get confused. Pay attention to the signs in the problem. And remember, once you start multiplying, you're allowed to cancel if something cancels. Since nothing cancels, we just take 1 times sine squared and cosine squared times 1 when we multiply the fractions. All right, those are a little tougher. Let's do another one. Okay, how about this one? When you see ones and squares, this is like the last one we did. When you see ones and squares, you should be thinking about that colored sheet. You have 3 identities that involve ones and squares. Tell me about one. Go ahead.
Isn't it sine? Isn't the top sine squared?
It absolutely is. That's written on your colored sheet, or at least it should be at this point. You have written on your sheet sine squared equals 1 minus cosine squared. So when you see a 1 minus cosine squared, you can just change that into a sine squared. Because 1 minus cosine squared is sine squared. Well, now what happens?
Take a 1 out.
Take a sign out. Yep, we can cancel out one of the signs. And so we're going to be left with sine over 1, which is just sine. We can cancel out one of these. And that leaves us with sine over 1 or just sine. All right, we'll do one more. Here's another problem. Now, a second ago, I said to you, let's think about those equations on that colored sheet if you have a squared and a 1. So if you had a little...
You can change that.
I can change it. I can. What can I change?
Tangent squared.
All right, let's talk about that. Let's look at that. There's a formula that says 1 plus tangent squared is secant squared. So do you see what Leah did? That was Leah, wasn't it, that was talking? You see what she did? She subtracted 1 from both sides. And if she does that, what does that equation now say? Tangent squared equals secant squared minus 1. This is on your sheet, but you can rearrange that stuff. So if you want the 1 with the secant, move the 1 over there. So secant squared minus 1 is tangent squared. So I'm going to rewrite my problem as tangent over tangent squared. This is tangent squared, just like she said. Well, what happens now? It's kind of like this one we just did.
1 over tangent.
Exactly. I can cancel out the tangents, only this time the extra 1 is in the bottom. So I have 1 over tangent. Now, I'm not going to complain about that answer. I think it's fine. But can anybody maybe simplify it even more? What's 1 over...
Cotangent.
Exactly. Cotangent. If you left it as 1 over tangent, I wouldn't mark that wrong. But cotangent is the most simplified answer. Okay? So we're going to forge ahead a little bit. So I want to be clear that you understand the expectations. First of all, your homework over 5.1 is due Tuesday. Okay? It has been videoed. Lindsay and I worked through it this morning. Doesn't take that long to do, does it, Lindsay? It's pretty short. But it's all on video, which I will be posting later today. That's due Tuesday. We're going to continue practicing a couple of these for a couple of days, and then we'll have a quiz. I will let you know when that is. The quiz will have 2 problems on it, exactly like the 2 kinds we just practiced. One with a big long string of, sine, secant, cosine squared, whatever. And then one where you've got to use your squared formulas, your squared identities. And we'll continue practicing that. You will not, and I'm not changing my mind, I'm not backing down. There are 8 identities you need to have memorized. So on that colored sheet, the 8 I had you circle, you need to know those. By the time we take the quiz, you need to know them. I think you can see that if you don't know them, you're going to be in trouble. So get them memorized. It's not a lot to memorize. So that takes care of that. Does anybody have a question before we start section 5.5? All right. Let's turn the page of our notes then. We're going to start section 5.5. You will need a calculator for this. So if you don't have one with you right now, please pay attention so you'll be able to type it in when you do have a calculator handy. We are going to now do what I think is the much easier part of this chapter. We're going to go back to working with triangles. The difference, well here, let me put the first triangle up here, and you tell me what the difference is. Does anybody see a difference? What?
That there's 2 degrees.
Well, okay. And that triangle is not a right triangle. So we are going to look today at our first work with non-right triangles. Now, what does that mean? Well, that means there's no more SOHCAHTOA, because remember, SOHCAHTOA means you need a hypotenuse, and we don't have a hypotenuse. So you will not be using SOHCAHTOA, and you will not be using the Pythagorean theorem. The Pythagorean theorem is awesome. We used it a lot in chapter 4, but that's because our triangles were right triangles. So we need some new strategies to solve this triangle. So let's get the basics out of the way. When we label a triangle, the angles are labeled with capital letters. So capital A means angle A, capital B means angle B, and capital C means angle C. So one of the things you're going to have to find is angle B. The sides are labeled with lowercase letters, and they are labeled across from their angles. So if this is angle A, then this is side A. If this is angle B, then this is side B. And if this is angle C, then this is side C. So capital letters for angles, small letters for sides, and the sides are labeled across from their angles. So this is side A, this is side B, and this is side C. Now those are the rules of labeling your triangles. All right, anybody have a question so far? So the directions say solve the triangle. What that means is find everything you don't know. So I don't know angle B, I don't know side B, and I don't know side C. So those are the things I need to find. A triangle has 6 parts, 3 angles, 3 sides. You will always be given 3 of them, and you'll have to find the other 3. Now, I bet everybody in the room or everybody on the screen here can find angle B. What are we going to do in order to find angle B? Think back to geometry. What do we know about our triangles?
You gotta add up the angles you know, and then 180 minus, 180 minus the angles you know.
Exactly. We know, thank you, Gabe. We know that the angles of a triangle must add up to 180. If you have forgotten that fact, please write it down and highlight it. You need to remember that the angles of a triangle add up to 180. All right? Now, that's easy. I'm going to put that over here in my triangle. In order, did I do the math right? Did you get 72? Someone nod or something?
Yeah.
Okay, great. Now, in order to find the sides, remember, there's no SOHCAHTOA. So never, ever, ever say sine equals opposite over hypotenuse. You can't do that because there isn't a hypotenuse. So instead, we're going to use what we know as the law of sines. I'm going to write it down here. The law of sines. And it is a very easy law to use. You're going to enjoy it. The law of sines says that the sine of angle A over side A, remember, angles are big letters, sides are little letters. So the sine of A over its side equals the sine of B over its side equals the sine of C over its side. That is the law of sines. So once, you found that angle there, I want you to look at the picture, and do you have an angle and its side? So do you know already angle A and side A, or angle B and side B, or angle C and side C? Do you already have a matched set?
You have A.
I have the A's. So that's where I'm going to start. That's where I'm going to start. I'm going to go ahead and erase this because I don't need to have this written up here. So I'm going to start by saying sine 38 over 16. That's this fraction right here. The sine of angle A over 16. Now, I'm just going to go with B. It doesn't matter. I could do C, but I can only do 2 at a time, so I'm going to go ahead and do B. And I'm going to say sine 72 over B. So I want you to look at my law of sines and look at what I wrote, and does it make sense? Sine 38 over 16 equals sine 72 over B. When you use the law of sines, you can only do 1 equals at a time. So it doesn't matter. You can do A and B, you can do B and C, you can do A and C. It doesn't matter which pair you use, but you can only do 2 at a time. 1 equals is all we have room for. So does that make sense to you? Well, what do you think I'm going to do now? How do I go about solving something like that?
Cross multiply?
Absolutely cross multiply. So B times sine 38 B times sine 38 equals 16 times sine 72. So B times sine 38, 16 times sine 72. Now remember, you are trying to find side B. You're trying to find B. So what are we going to have to do now in order to know what B equals?
Divide sine 38.
Exactly. So B will equal 16 sine 72 over sine 38. So this is where I need my calculator. Make sure you're in degrees. I'm not sure how you're set up. So if you're using a calculator now, make sure you're in degrees. These are all degree problems. We won't be using radians in this chapter. All right, and then I'm going to type in 16 sine 72. Now remember, when you hit sine, you get parentheses. Make sure you close those. Divided by sine 38. And I got, for side B, I got 24.72. Anybody else get that? Okay. All right. Does anyone have a question so far? We're almost done. All that's left is to find side C. Do not think about the Pythagorean theorem, guys. It's not a right triangle. So, what do you think I'm going to get to do then to find side C?
Sine of 70 over C equals sine of 38 over 16.
I love it. You're absolutely right, Gabe. Sine 38 over 16 equals sine 70 over C. In other words, I'm doing the same thing all over again, but this time I'm looking for C. So I'm using 70 and C. The first time I used 72 and B. So I'm going back to the pair I knew, 38 and 16. So sine 38 over 16. And then I'm looking for C. So I'll do sine 70 over C. All right. So what do I do next? Once I get my law of sines proportion set up, what do I do next?
Cross multiply.
So C, yes, very good. So C sine 38 equals 16 sine 70. And then remember, we are solving for C, right? So we'll do what to get C by itself?
Divide sine 38.
Yep.
Divide.
Yep. By sine 38. So C will equal 16 sine 70 divided by sine 38. And I'll be real careful to close the parentheses around that 70. So 16 sine 70 divided by sine 38. I got 24.42. That's really close to the answer I got last time for the other side. And that makes perfectly good sense. Can anybody explain to me why it makes sense that those two sides would be so close together in length?
The only thing different about them is 70 and 72.
And those two numbers are very close together, aren't they? So it makes sense that since the angles are so close together, that the sides would be close together. Very good. Very good. All right, we're going to do one more, guys, and then we'll be done for the day. JP's yawning. I can't imagine yawning through the law of sines. This is so cool. Let's look at problem B. Here we go. Now we have triangle DEF. So this will be side D. If you're confused, look up here. This is going to be side D. This is going to be side E. And this is going to be side F. And we know that D is 8. Is there anybody that has a question about the labeling of that triangle? Okay, what's the, oh wait, I know some angles. This is 48 and this is 71. All right, what's the first thing you're thinking about doing?
Finding the out of the other.
Absolutely. We're going to find the other angle. So tell me what you get when you find the other angle. Yep, that's what I got. Is that what everybody else got? All right, so here we go. Now, you always, always, always want to look for your pair. In other words, D and side, angle D, side D, angle E, side E, angle F, side F. That's where you want to start. So which pair do we have?
D.
Yep, so you're going to start with sine 61 over 8. That's what you're going to start with. If you're doing the law of sines, you will always have a pair. If you don't have a pair, like D and D or E and E, then you're not going to do the law of sines. It's not going to work. So we always look for that pair first. All right, then what? What do you want to say next?
Sine 48 over E.
Exactly. Now, could somebody else do sine 71 over F? Yes. We're going to have to do them both, and the order that we do it doesn't matter. So she said E. All right, let's finish this up. Here we go. What's the next step?
Cross multiply.
Yep. So E sine 61 equals 8 sine 48. Cross multiply. E times sine 61 equals 8 times sine 48. Then we need to get E. You want to know what E equals. So we'll
try sin 61.
sine 61, yep. So I'll just type this in on my calculator, right? Being very careful to close the parentheses. 8 sine 48 divided by sine 61. I got about 6.80 if I round to the nearest hundredth. Who's got a calculator? Is that what you got? Calculator people? All right. Let's finish the problem then. How are we going to find side F? What equation am I going to set up?
Sine 61 over 8 equals sine 71 over F.
Exactly. Is that you, Kennedy?
Yeah.
So sine 61 over 8 equals sine 71 over F. Now we'll cross multiply. That's what we do when we have a proportion. So F sine 61 equals 8 sine 71. And then we'll divide both sides. So I'm gonna type into my calculator 8 sine 71 over sine 61. 8 sine 71 divided by sine 61. And I got 8.65 for that one. You guys okay with that so far? We'll practice that law of sines a little bit more, but that's pretty easy, isn't it? Yeah, compared to the other stuff it is. All right, anybody have any questions for me? All right, well, y'all have a great weekend, and I will see you, I don't know, sometime. See you later.
Thank you.
Thank you.
Bye-bye.
Thanks, Miss Ford. Have a good day.
You too, Gabe.
Thank you.
Oh, shoot.